Today we will be going over slope intercept form of linear equations. We will write linear equations in slope intercept form using slope and y-intercept. The linear parent function, which is y equals x, is the most basic linear function and can be used to create new linear functions by changing the slope and or the y-intercept. In earlier lessons, we went over y equals mx plus b being our slope intercept form. The parent function to that, y equals x, is whenever our variables m and b, our slope and y-intercept, are neutral. In this case, slope would be neutral with 1, and our b, our y-intercept, would have to be a 0. For our phrasing, as soon as I get the right font, m is the slope, as I just stated, or it could be known as the rate of change. Our b variable will be our y-intercept. And make sure that I have it correct. It is a lowercase y, even though this automatically capitalizes. Slope is the rate of vertical change to horizontal change, which we can just refer to as the rate of change. When we are looking at a graph, we always want to read from the left side to the right side whenever we are looking at slope. This lets us know when we're going left to right, which is upward, it will be positive. When we go left to right and it goes downward, this will be negative. When it is a horizontal line, this will be the 0 slope. Now these lines are in the form of y equals some value, depending on where the y-intercept is. And then our vertical line. When we're dealing with a vertical line, it is undefined because our x is never changing. Our x is always some value. So we use the x-intercept for our equation, plugging in whatever value our x-intercept is. When I'm looking at the linear parent function, I'm looking at y equals x. Now I said whenever values were neutral. What I meant by that was our y-intercept is at the origin. It goes through 0, 0. Our slope goes up 1 and over 1. So if I were to use 2 points, I could use the origin. And the next closest location that is positive is 1, 1. Whenever I plug the values in, I have y equals 1x, my slope times x, plus 0. Now, we understand when we're multiplying by a variable, we don't need to show the 1. And when we're adding 0 to anything, we don't need to show it. So this is why it's called the parent function. Our two variables that we are changing do not have to be shown. 1's not shown and 0's not shown. When we are trying to identify the slope and y-intercept so that we can create an equation, our y-intercept is one of the easiest. It is 1 point wherever it crosses the y-axis. I'll label both of my problems real quickly. So in this case, my first problem. Make sure I have the right type. Y-intercept is a location, so I need to put it in ordered pair. X value for every y-intercept will always be 0. And in this case, the y-intercept value will be 4. For my slope, I can choose another location. I'm going to link back up with our last set of notes and use our x-intercept, our 0 value. When I do this to find the slope, I want to figure out how much it goes up, in this case, a value of 4, and how far over to the right that it goes, also 4. Our rule is rise over run. In this case, they're both the same number. It does not change. So when I use rise over run for my slope, I have 4 divided by 4, which is just 1. My equation for this, using my y-intercept value and my slope, would be y equals my slope in this case is 1. So I would have 1x. I can just type x. And then my intercept is a positive 4. In this case, I'll use a different font for my 4 because this is the only part that is changing for my equation. So looking at this, my y-intercept was 4, or 0, 4, sorry. It is a location, so I have to use it as a ordered pair. My slope, after choosing 2 points and turning them into a fraction of rise over run, I get a slope of 1. And when I plug into the equation, the only thing that is shown is my plus 4. So I have y equals x plus 4. For my second example, my y-intercept is downwards. In this case, x is still 0. My y value is a negative 1. Looking at my slope, I can use the x-intercept again, just for consistency. I would still go upwards, so this is a positive 1. And I will go to the right, 2. For slope, we want to make sure that we do rise over run. So this would be 1 over 2, which is what we cannot simplify. I do know that we have an equation in here somewhere. I know what it's under. So we have a positive half, or in this case, 1 over 2. For our equation, we still have y equals. We plug in our slope value. Of 1/2, and we're multiplying this by x. Since it is something that I'm changing from the parent function, I'm going to use the red font for you. And this time we have a negative 1. So when we add our slope intercept, we're actually going to be subtracting a value. We're going to be subtracting 1. So we have two parts that change. We have the slope value that changes from the parent function, as well as our y-intercept. Quick examples that I've already did. Our y-intercept was 0, 4. This time it's going down 4 and over 1, which will give me a slope of negative 4. And plugging it into the equation, I have y equals negative 4x plus 4. When we have our special slopes, in this case our zero slope, we have a set y value, and our x can be any value there. We do not have a changing slope. So since our slope is 0, if we were to plug it into the equation, we would have y equals 0x plus 4. And we learned earlier on that 0 times anything is just 0. That is why we are only left with the y equals 4.